Good afternoon, everyone. Excited to be here to learn about SDN today? Yeah? All right. You excited to go to Universal after this? All right. One of my favorite rides at Universal is the Jurassic Park ride there. If you've read the books or seen the movies, you've learned what the dangers are in running an amusement park with real dinosaurs. I mean, if things go wrong, they eat you, right? Universal took a different approach, probably a smarter one, in that they built robotic dinosaurs that, are virtual dinosaurs in that respect. And they didn't just plop those dinosaurs down in the middle of, some Florida swampland where anybody can go up and look at them. They, on top of that swampland, they built a layer of paths and landscaping to really give you the feel of being in, a real Jurassic Park. And they tied it together with paths that go through there for the users of the park or of this attraction to go through to get to the ride, and separate paths for the back end to go through. And you know where I'm going with this. And they even added on like services that can go, for the people that are going through these paths, things like the gift shop, which they almost force you to go through at the end of the ride, and the restaurant. And it's really a great analogy for what we're doing with SDN, right? SDN is all about building up a virtual layer so that these attractions, which are your VMs, also virtual, they have the full landscape of what they need around them. And then, at Universal, they also are able to then create a completely different landscape right next door in the same park on the same Florida swampland. They can build Harry Potter, or they can build, a Spider-Man ride. Whatever they need, they can create it, there. So that's my introduction. It's something for you to think about while you're waiting in line for your ride tonight. So with that, we'll get started. We're going to talk about SDN, and I'm going to really talk about one theme throughout this session, and 3 points that emphasize the theme. 29 is the year that we really think SDN is going to go mainstream with Windows Server. And there are 3 reasons why we think that's the case this year. We've got great features. We've been talking about these for a long time, and we've added more in 2019. So I'm going to talk about existing features from 2016. I'll talk about what's coming in 2019. And you'll see, what we got, and you'll really want to use it after you hear about this. The next thing we've added, and this is probably the most important, is we've added additional management options. Through SCVMM, of course, you've been able to manage there. And for those of you that need the power of VMM, it's a great tool. But we've also added an easy option through the Windows Admin Center. The Windows Admin Center is very lightweight. It's easy to install. It's easy to set up, and there's very little that can go wrong with it. There are also third-party options that I'll talk about as well coming up later on. So you actually have a number of different choices depending on what meets your needs. And then finally, we know that one of the challenges with SDN is bringing it up, getting it running, and actually just getting to that, past that day one where you're doing your setup. And so we've been really working to make the actual installation of SDN easier than ever, both, again, through VMM and through our standalone scripts called SDN Express. So let's jump in first, start talking about the features. So why do you want to use SDN? Right? We really put the features into 3 categories: security, flexibility, and then savings that you get from SDN. Security, you've heard about this probably for a long time now when SDN first came about a few years ago, is that virtual networking gives you this layer of isolation that lets you protect, not just, other things, the one user from another user, but it lets you protect applications from each other. It lets you protect tiers of that application from another tier. Because, you have to assume these days that any VM can get breached, it can get compromised. And so you want to be able to limit the damage that can happen from that. And so you have the ability to create a virtual network that isolates the application, micro-segmentation that isolates the layers of the application. And then starting in 2019, we've added flow logging so you can match security rules in the micro-segmented firewall to be able to log then the hits of either the allows or denies, so you can start to see if, what's going on in your network if you're under attack. Another thing we learned from talking to a lot of customers, and I actually talked about this at Ignite last year, is virtual subnet encryption. A lot of customers, they have applications that they say, that 95% of the applications are encrypted. When they look at the encryption, well, the type of encryption that's used, because they're legacy applications, is no longer secure. So by adding a layer of having the SDN layer do the encryption for you, now the communication that takes place is, using a modern encryption that is secure. and can be updated if it becomes unsecure later on. Finally, on security, what we have in box doesn't do everything. You have compliance. You have regulatory needs for, certain third-party devices and technologies. And so we want you to bring those in. We want you to keep using all those partner technologies and appliances that are out there that, bring that extra value you need, that deeper packet inspection. So that's where the ability to bring these appliances in. The other thing is there's also a lot of open source out there, Linux-based toolkits and projects that you may want to use. And historically, if you don't have SDN, you have to set up a machine for that, and you have to hook it up to your network so the traffic goes through it and, deploy onto there, do it all yourself. Now with, SDN, you can create your own virtual appliance, deploy your own software in there, and, use whatever packages out there that you want. Now, in the category of flexibility, of course, the isolation gives you additional flexibility because you can bring your own address space, reuse address space over and over again. We can bring in these services. I mentioned the restaurants and the gift shop. Well, here's the analogy to that is load balancing, DHCP, NAT, VPN. These are all things that we have in box that's available to the workloads to use, all by just, telling the virtual network, hey, make these available. Virtual appliances aren't just for security. You do load balancing with them. You can do WAN optimization, whatever you want to do. You can do it in a load balancer. So it's not just for security. I mean, it's for flexibility. It's also for savings. You don't have to bring in the box, maintain that box, hook it up, and troubleshoot the physical aspects of it when it goes wrong. Quality of service is something we don't talk about a lot, right? The ability to put a VM that has, very large packets with lots of throughput, these, what are often referred to as elephant flows, that could then make it hard for, this very high frequency, very small packet, these mice flows, to get through on the network. Well, with quality of service, we can essentially, help to guarantee that both types of workloads can coexist on the same machine and not starve each other. And then finally, really focusing on savings. Not everyone wants to start with a 16-node cluster and, start to fill it up. You want to start small. In fact, most of our, hyper-converged solutions are 2-node systems that people buy because of their simplicity. They can get started, and then they can add more later on when they need it. And so with SDN, you can start with that 2-node, and then as you add more clusters later on, as you outgrow that, and even though those clusters end up in different subnets, you can extend the virtual network across, give you that flexibility to, again, start small and then grow as you need it, so you don't spend as much upfront. And then finally, everything I'm talking about today, as far as SDN, all the components you need are included in Windows Server Data Center Edition, so you don't have to buy anything extra beyond that. If you have S2D, then you have a data center already, so you're good. And we've done a few changes to the WSSD program that I'll talk about to make SDN even more available. So we do it all through essentially 4 roles in Windows that do all this. So if you do get Windows feature on a server data center edition OS, you'll see what's down at the bottom. It lists the 4 roles, and they're made up of the network controller. Network controller is essentially the brains of everything. It's your control plane. It's what goes out, takes commands from the management application, whether it's VMM or Windows Admin Center or something third party. Takes those controls and then distributes out the individual commands for the Hyper-V hosts or the load balancer and gateways to go do the work. We have a network virtualization role that essentially enables the data plane and the agents in the Hyper-V host. In Server 2016, this role didn't exist. We actually enabled those or put them in place whenever you enabled Hyper-V. So in 2019, we separated it out into its own role. So if you look at 2016, you won't see network virtualization as a role. But that's what runs on the hypervisor. So you enable it on every Hyper-V host. Remote access, it's the same remote access you've known and loved for a really long time. We've been working on improving the throughput. I'll talk about that later. But it is your routed entry point into and out of your virtual networking. And it can provide a number of different mechanisms for connecting that virtual network, whether it's just straight L3 routing or a VPN tunnel or a GRE tunnel. And then finally, the load balancer. This is our way to load balance into the system. It's multi-tenant. It's active-active, highly distributed, and very efficient in how it processes the packets. It also performs NAT for the virtual network so they can get back out. Once you have all this in place, and these are all the things you can do, I mean, it really is a full-featured SDN system. I'm not going to go into all this. We call this a wall of features. S2D has one of these. The Hyper-V team has one of these. But, it basically gives you the scope of all the work that we've been doing. And really what I'm going to focus on next and for the rest of this section is what's new in 2019. because this is really what you're interested in. We're shipping 2019, and these are the new things. Excuse me. So before I get started, though, I do want to mention one thing about SDN Windows Server 2019. I don't know if you've heard this already, but really we're waiting for the GA of the hyperconverged components, so S2D and SDN, to be available in January. So what's going to be available next week will not have these components enabled yet. We're working with the hardware vendors and hardware partners to bring the WSSD certified solutions to be ready in January, and then we'll push an update that will enable SDN and S2D for these customers. So the key thing, though, for all of you, if any of you have deployed 2016 and are using that in production, don't upgrade it to 2019 yet, because it'll upgrade the network controller, but it won't actually put it into a 2019 state. You'll still be running on the old 2016 network controller code in there. So we recommend you don't do that until January when that's updated. But then in January, what do you get to do? Well, things like encrypted subnets. So this is one thing that's new. I talked about it a lot last year, so I'm not going to go into as much detail this time, but it really does automatic encryption, as I mentioned. There is a performance hit when you enable it. Our benchmarking shows you can get about 1 gigabit per second, because it's very heavy on the CPU, and it does get pegged to essentially one core in the CPU, so it does limit the throughput for those machines that have the encryption, that are on the subnet that have encryption turned on. So you do want to be aware that there's a performance impact. Configuration is fairly straightforward. We'll be updating SDN Express for deployment. VMM will actually do this configuration for you as well now when you get their update in January as well. But basically, you enable it by putting a certificate on the host that's for encryption and decryption. You map that certificate to the virtual subnet and basically say from then, or the virtual network, and then you say, for each subnet, I want encryption on, off, whether you want it or not. Now, the encryption doesn't restrict any traffic. SDN is smart enough to say, well, if I'm in this flow is going to the same subnet, then encrypt. If it's going somewhere else that isn't encrypted, let's say you're going out to the internet or you're going to a different subnet, then it won't encrypt that traffic. And the encryption doesn't do any restriction on where you're going to go. And so if you want that restriction, then you apply the access control list to enable the firewall to apply the restrictions you want to force that traffic. If it's port 80 HTTP, you may want to stay within the encrypted subnet so that it doesn't go out where it's not supposed to. So who knows what this represents? Anybody want to shout it out? It's a VXLAN packet, essentially, the VXLAN header, right? You have the outer Ethernet of the VXLAN, the outer IPv4 header, actually I'll bring up the pointer, right in the middle is the UDP header for the VXLAN packet, and then the VXLAN packet with its the VNI, the virtual network identifier, is right in the middle. Then below here, at this point, you get to the inner Ethernet. This is now the packet that the VM sent, and here's the payload down here at the bottom. And really, that payload is then made up of its own set of headers. This is an example of a TCP/IP packet. So you have the IP header at the top, TCP header then down below, and then your data, your top secret stuff that you actually want to protect is down there. When you turn on encryption on the subnet, literally everything in that block disappears. It's completely invisible to anybody that tries to sniff this packet. You can't see that it's even an IP packet on the inside. You can only see the outer VXLAN component of it. If we actually look at Wireshark, what it does, right? If you look normally when you sniff the traffic, you'll see this is HTTP is all in green. Up in pink is some ICMP. So you can see that this VM is doing pings. It's doing port 80 HTTP gets. As soon as you turn on the encryption, you don't touch anything in the guest. You still see that it's VXLAN. The middle section parses it out. You see the VXLAN header there. But then down below, where you had the actual payload, it's just data. Wireshark can't even parse it out. So that's really what the encryption does for you. So it's a great thing. You don't have to do any configuration in the guest. Very easy to turn on. VMM has basically made it a checkbox that you do to turn it on. So the next thing, you've got your network secure. You've been able to use ACLs on the network. You want to be able to do logging of those ACLs. And so we've added an ability. If you set on a rule in your access control list, you want logging, then this will basically enable that for you. The logging takes place on the Hyper-V host. So the Hyper-V host is going to go and write to the location that you specify. Typically, you'd want it to go to either the CSV, so it's a common place, or an SMB share, so that it's all in one place where you can then pull it in and analyze it when you need to. And so we give you that ability to do that through the network controller interface, PowerShell interface, to set it up. And the format that we use for this logging is consistent with Azure Network Watcher. So one of the things that we learned over the last few years as Azure has built out Network Watcher is that an ecosystem of partners has sprung up around the format that they use when they put their flow logs into a blob store. There are a number of partners who can pull out of that blob store and then basically analyze and process and bring these into other tools like Splunk or Power BI. And that's what I'm going to show you, is using the Power BI template that Azure made available. With just a few modifications now, it can be used to process these flow logs. And each host will log its own log with a GUID identifying it into the directory. And it flushes it once per hour. So it's every hour it'll flush, create a new file, and then start writing to a new zero-length file that you'll see in a minute. Let's go take a look at how that looks. So here's my SDN environment. So it's a Hyper-V set up with 3 nodes. You can see I have the SDN components up at the top. I have a few tenant VMs. Is it actually moving? There we go. I have a few tenant VMs on here as well, on each host, kind of distributed across these 3 hosts. So it's fairly straightforward. MUXes and gateways are deployed as well. And so what I'm going to do is I'm going to go to PowerShell, and I'm going to enable SDN logging. Now, this is going to get added to SDN Express, so by January, this will be just a matter of specifying the path where you want these to write. Basically, what we're doing with this list is, this script is saying, creating an object on the controller saying, here's where I want the logs to go, and then on each of the servers, telling it to enable logging. And then I run it. You can see I've actually run it already even before running it this time. And I've actually been running it for about 4 or 5 days now in this environment to be able to generate a full list of logs. You can see here are the logs. You can see I've sorted by size. Those top 3 zero-length ones are the current set. So I don't want to actually open those up yet. And the template will take care of that. Before we go to the template, I've switched to another machine that has Power BI and Visual Studio Code. Visual Studio Code is a good tool for actually looking at JSON, because when you open up JSON, normally it looks like this. But if you click in the right place, you can do Format Document. Now you can see, here's what's actually in here. It's basically made up of all these records of the individual flows. So here's the flow. This is one of the tuples that represents source and destination IPs, ports, the action, whether it was allowed, whether it was inbound and outbound. So all of that is in this file for each flow. The port information lets you identify which machine it was that was actually creating this flow. So that lets you find the VM. We say which rule it actually applied to. And so this is, if you actually open up one of your blobs from Network Watcher in Azure, you'll see something that looks almost exactly the same. So now let's go into Power BI and open up this template. So this is basically I took the template that Azure has available, brought it into Power BI. I made a number of modifications to it along the way. I'm not very good with Power BI, so but I was able to get it to basically, instead of pointing to a blob store, enter in the directory path of where these logs are located, and then it's going to read in the logs. I have to tell it how many hosts there are, so it skips those first 3, and then it reads them all in. Takes a minute because there are quite a few. If you do have weeks or months worth of files, you probably want to narrow down to which ones you want to actually look at if you're using this tool. And this will be available on GitHub, on our SDN GitHub repository. We'll have this available by January as well, so you'll be able to download it and use it and see it as an example. And as it loads, you can see here, I'm going to actually just pause it here for a second. You can see here in the top left corner are essentially all of the top destinations. So you can see here, these 2 boxes here represent some DNS, some MDNS queries that take place. These are broadcasts that get filtered out. Down below are some of the actual traffic that that the VMs sent that are not broadcast. This section up here shows a chart of flows inbound and outbound and which direction they went in. So you can see if there's a lot of outbound, see if there's a lot of inbound. This one down here shows was allow or deny. This is actually a very important section of the chart, because if you see a spike in denies all of a sudden, then that's potentially somebody probing, hey, can I get through to these ports and trying to find a way through. So let's get this going again. Turn off my laser pointer. And so one of the things that you can do, one of the great things about Power BI is that you can actually go in and start to filter and drill into what parts of this you find interesting. So here I'm going to go, and first thing I'm going to do is I'm going to go down to the bottom where we have some filters, so where we can narrow down the date. You have some other filters. You can filter by, source IP, destination IP. If you see a destination that you find suspicious, you can go and, look at who are the people talking to that, or a source. You want to know who's this VM talking to. And so here we've narrowed it down to a specific day. You can see there's a spike right there. If you click on that, it'll actually show you and filter down below the section that shows you, okay, what's the source of that spike? All the sources that caused that. What are the destination IPs right there? Those two I know are my Active Directory servers. And if I look at the ports that they're going to, I can see that these are, fairly typical Active Directory. I see some Kerberos. I see some RPC. I think there might even be some SMB in there as well. So that all looks normal. I can then even go to which VM and server based on these GUIDs. I can then go to the host and find that VM if I do need to quarantine or do something there. So this just shows you now what you can do now by flow logging and using a tool like Power BI. All right, let's move on. IPv6, that's one of the other capabilities we added. That's new in 2019. Basically, we started out with IPv6. We really wanted to get to Azure parity, basically being able to support IPv6 for your VIPs, because that's really one of the areas that are internet routable that customers are running out of first. But as we went along, Azure is also building in, working on v6 in other areas. And so we actually started to expand the list of what we currently support for v6 to really try to expand to cover the entire gamut of what can the virtual network use or need to use. And so everything on the left is what we've currently tested, validated, and have support for. The column in the middle represents what we also know you can set v6 addresses on, but we haven't validated yet that those actually work correctly there, that all the plumbing is in place. And we plan to finish that up by January when things are fully available to everyone. There are a few places where you can't use v6. The management address space still needs to stay v4. Generally, from customers that we've talked to, it's not a big deal because that tends to be private address space anyway. So you don't need to use v6 there, and so you can't. The other limitation that you may run into is that on the load balancer object, each load balancer object can only have a single front-end VIP. What that means is you can't put v4 and v6 on the same load balancer object. You can create two different load balancer objects, and map them to the same backends, but then they're on different objects. And where that'll impact you is on the site-to-site gateway. The site-to-site gateway, in order for it to have its endpoint VIP that it shares among all of the gateway VMs, it has a load balancer object that you use behind the scenes. And because of that, it'll only have either a v4 or a v6 on it, depending on what you've assigned. So that's one limitation where you can have v6 and v4 on the same gateway pool. You can create two gateway pools, but then you also have two sets of gateway VMs. We do support dual stack for the virtual network address space. You have to map one-to-one a v4 to v6 when you use that within each subnet that you want to have dual stack available. If you do use v6 in your virtual address space, and you also do have to have the physical address space for the provider network, where the VXLAN packets go, also have to use v6. We don't do v4 on top of v6 and vice versa there. So virtual network peering is another very much asked for capability that we've added in 2019. This basically lets you connect two virtual networks together. As long as their address spaces don't overlap, then the VMs can send to each other directly, almost as if they were a single virtual network. Where this is useful is for scenarios where you deploy a database into one virtual network, and you set it all up with whatever security at once, and you leave that database there, and then you start to deploy a bunch of different applications, each into their own virtual network. You can then create and destroy those all you want, but they can all use then that same database and can go and reach across to that database all within the private address space. So that's one of the scenarios. Other scenarios are sometimes you migrate other services in that are in a virtual network and you need to connect them together. So those are some of the common use cases. It doesn't use gateways. So the SDN system and the controller is smart enough to basically program the host so that VMs sending across these peered networks talk directly to each other. They don't go through gateways, so there's no bottlenecks there either. And then, of course, when you have two virtual networks, each one can have its own set of gateways. And so as part of setting up the peering, you will also define which gateway is going to get used for traffic that's going to be egressing from there as well. So we'll show you this right now real quick. And so here, you can see there are two VMs. These are just some simple Linux VMs. They're connected to two different subnets. Linux works great within SDN, by the way, so I like to show that every now and then. And here you can see this VM on the front is pinging a VM on its same subnet, so it has connectivity, everything is happy. The VM in the background, the 10015 address, it's not reachable. So it's on a different virtual network, and when I ping it, basically nothing happens. So what I'm going to do now is I'm going to enable peering. And so this script here, it's basically two commands you have to run to enable the peering. You get the two virtual networks you want to peer together, and then for each one you have to say, okay, allow peering, and who do you want to allow peering with? Well, so in this case, the first one I'm going to peer with VNet2, and VNet2 is going to peer with VNet1. And then you have a number of properties in the middle that say, okay, well, are you going to allow each of them to be able to talk to each other once they're peered? Are you going to allow traffic to get forwarded through one to get to another through the gateways? Are you going to allow them to even use the gateways? Things like that. So you set all of these for each of the networks, and then once you run it, it's going to run right now. Just takes a few seconds to run, and then by the time you switch back to the VM, you can see already the pings have started flowing through. So basically all the policy got updated on the hosts, and now the traffic flows as if they're part of the same network. So that's peering. This all does work within a single network controller, so we don't do cross-network controller peering at this time, so that is one limitation that you should be aware of. Another area that we've really worked at, in 2019 is in the gateway performance. We've heard from customers that, if you've used GRE tunneling in particular with 2016 or even 2012 R2 with HNVV1, GRE tunneling has, left a little something to be desired in the performance area. I think even this chart is a little generous for how much throughput a single TCP connection will give you with a 2016 GRE tunnel through the remote access gateway. For GRE and for IPsec, we've actually worked really hard, and we've actually improved performance by at least 3 times for both types of gateways. Here, this chart here shows GRE tunneling. Single tunnel gives you 3 times the performance. Blue is 2016, green is 2019. As you scale up the number of connections, the throughput, just keeps getting better and better. And we do this at the same time while using fewer CPU cycles at the same time. And the way we do this with GRE in particular is by using the hardware offload in the physical adapter of the host. We're able to use the SDN policy to program the virtual switch to basically do the GRE encapsulation in the host without actually sending it even into the gateway VM. And so that's how we're able to get 18 gigabits per second through a GRE tunnel. That's actually faster than what we get through forwarding through these gateways without the GRE encapsulation. So that's pretty impressive. So let's just show you that real quick in action. Now this is actually this demonstration is going to show IPsec. So this is going to show site to site, where we also have a 3 times performance improvement. It's not quite as dramatic as GRE. So first we're going to start a tunnel. This is all 2019 we're demonstrating here. A single connection. So this is using a tool called CTS Traffic. This is actually available out to the public. I think it's on GitHub as well. It's a tool we use for doing synthetic traffic. And here we're starting from outside the virtual network. We're going through a site-to-site tunnel into the virtual network. It's a TCP connection, and we're going to do one single TCP connection, and it's just going to start to transfer. I don't even know how many terabytes of data that is going to transfer, but it's a lot, so it won't stop. And so there you go. We have the connection going. And we're going to bring up, this is now connecting to the gateway, where we're going to bring up just the task manager on the network adapter for the back end of the NIC of the gateway. And you can see right away the chart has gone up. It's a little hard to read, but you can see in the bottom left, we're getting about 1.8 gigabits per second. This is on a single TCP connection going through an IPsec tunnel. This is already more than we were getting as an aggregate, through a gateway of all the connections before. So we're getting almost 2 gigabits per second here. So that's pretty interesting. Now let's see what happens when we do more TCP sessions. So we'll let that run for another second. So we're going to go back to the same window where we launched CTS traffic. We're going to stop this one. And we're going to change that parameter to change it from being 1 connection to being 16 connections. And we're not going to just do it for this one, but we're then going to go to 8 other machines and do the same thing. So here we go, changing connections to 16, and enter. And if you do the math, 16 times 8 is 128. So you have 128 connections going through this site-to-site tunnel. So this is a single tunnel that these are all going through, starting them all up. And so we're really parallelizing and really, realistically utilizing as many CPUs and cores as we can to send the traffic. And now when you look, you can see the charts going up, up, up. And when we zoom in there, you'll see down in the bottom corner, we are getting about 4.8 gigabits per second, maybe even 4.9 at the maximum. That's IPsec tunneling. If you connect this tunnel to Azure, I'll tell you a little secret, this end of the gateway won't be your bottleneck. It'll be the Azure side. So you may not actually get this if you go to Azure. Okay, so that's gateway performance. So we really spent a lot of time on that because we found that is one of the limiting factors of, what someone can do with SDN. The GRE one in particular is something that customers have wanted to use for a long time, but, because of the limits of throughput, they couldn't get what they wanted out of it. And now because the GRE is useful in particular for stretching, getting your virtual network to reach to other parts of your data center while maintaining the isolation and not touching every hop in between. So. All right, so that's it for the 2019 feature. And one other thing I want to talk about is, actually, that's it for the 2019 SDN features. One other thing I want to talk about is one of the changes we made to the solution categories for Windows Server Software Defined. So, you've seen us if you've been to the expo floor. We've been talking about Windows Server Software Defined. It's the hardware and software specification for partner solutions that, work great for SDN, S2D, and the entire software-defined data center. What we changed in 2019 is what used to be premium is now standard, and we've basically defined a new premium. But what that means to all of you here for SDN is that SDN now is part of every, WSSD certified solution. It has the hardware, the VXLAN task offload that you need in order to be able to run SDN really well. There are a couple things that we did add to the premium specification, though, for WSSD. These are things related to performance because it does require hardware offloads in the network adapters. A new feature called Dynamic VMMQ and Guest RDMA, so the ability to send RDMA into the guest. These aren't things specific to SDN, but I did want to mention them because they do affect SDN. We'll be talking about these more. There's actually another session on networking tomorrow morning, so we'll talk about these in a little more detail. The other thing that is available to everyone, and actually to every Hyper-V user, it's enabled by default now in the virtual switch, is RSC in the vSwitch. And this is something that really gives you more throughput and less CPU utilization essentially for free, on the same hardware. Essentially, it goes from, in this benchmark that we ran, we started out at 31.6 gigabits per second at 44% CPU utilization. And when we turned on RSC for the first time, we actually almost cut the CPU utilization in half while increasing the throughput at the same time. So this basically gives you more of that CPU back to your workload, so you can run more VMs, use more of your capacity for what you actually need it for, which is the workloads. All right, next thing I'm going to talk about is, what I'm going to say, the section on easy management, right? We've had VMM for a long time, and for VMM users that really use the power of VMM, it's actually a great tool. It has SDN integration. You can do deployment of SDN through it. It's great for where you have different mixed types of hardware. They're not all kind of the same design. It has templating. It has the Windows Azure PAC. I had to get that one right because we have enough acronyms like that. It has Windows Admin PAC Windows Azure PAC that gives you the self-service portal. So it actually has a great set of features, and it actually is easy to use once you get used to it. Windows Admin Center is now the new kid on the block, right? It's designed to be very lightweight, to work with very consistently defined hyper-converged systems in particular. And it gets ships at a fairly high cadence. We can have features out almost every month we really wanted to. And it's a free download, and it really lets you very easily manage your hyper-converged systems which a lot of you are actually buying and using, starting out, as I said before, in 2 nodes, going on up. And so we really started focusing on building in SDN features into the admin center because we really think this is the easiest way for someone to get up and running with SDN and actually be able to use it with as little of the overhead of, knowing, networking as possible. The other thing also that is new as well this year is we have third-party management tools available. So if these don't meet your needs, 5.9 has been working with us for the last year or so using our REST interface, which is a public API. It's available to any partner to use. 5.9 has been working with us to bring integration of SDN into their cloud manager. So if you have a Hyper-V environment on premises, you have Azure capacity in Azure, you can manage it all from a single tool, the 5.9 Cloud Manager, which I'll talk about a little more in a minute. So the rest of this, I'm going to really focus on Admin Center because that's what's new. VMM does have a few new things related to SDN as well. They had a talk yesterday, or a session yesterday, where they talked about some of these. They've added support for encrypted subnets. It's very easy to turn on encrypted subnets. They've added layer 3 gateway configuration in their UI. So now you can actually set up your virtual network to talk to a VLAN without using any PowerShell. So that's a great thing, really makes things easier. They've added support for floating IP via SLB, so you can have a cluster. With the right settings, you can float that IP using an SLB VIP. And they've actually added support for LLDP as well. So your host connections, they enable LLDP, they listen to the events coming through it, and then they'll show that port information from the switch through LLDP and make that available to you. So they have a great set of tools there as well in 2019. But let's talk about Admin Center. And our marketing team would get mad at me because I left Windows Admin Center off the front of that, but SDN Windows Admin Center. We have SDN integration that we started and is now in preview. It's actually available to all of you now to try out and start using. It is tied to the hyperconverged cluster extension, so it has to be a hyperconverged cluster. When you add the cluster to Admin Center, as I'm going to show you in a minute, you get an option to add the network controller as well. But then it brings it in, and now you can actually, use the controller, entirely through the Admin Center UI. You have to deploy your network controller and your SDN components through SDN Express in this model. SDN Express is an easy-use tool. I'll show you that later as well. We made great improvements there, but that's how you'll bring it up. So it's very easy to use to get SDN up and running and deployed. And the one nice thing about Admin Center is that it doesn't have its own database, right? It's always talking to the network controller to get the latest state. You don't have to worry about anything getting inconsistent. If it's inconsistent, you just hit refresh on the Admin Center, and it'll just pull all the state in again. So that's a great thing because it also means then for that functionality that we don't have yet support for in Admin Center with the controller, you can do that through the controller PowerShell for now as we add in, and I'll talk about that roadmap in a minute. As we add in more capabilities, they'll get lit up automatically, and they should just, even the things you created through PowerShell will show up in the Admin Center UI. So what's the roadmap look like? Just to give you a little idea of the direction we're going in. So right now you have virtual networking, basic switching, routing. DHCP will serve up to the VM. When you connect it, you can connect the VM. So you go into the VM network adapter properties. You can connect the adapter. You can then live migrate that VM. Everything will get updated because that's the responsibility of the controller. And then we add an extension for the health of the infrastructure, the SDN infrastructure, so that from a very easy place to look, where, whether everything's healthy or not. Because that was actually something that was very much asked for. We are right now in the progress of working on adding logical networks, virtual gateways. I'm going to show these to you. This is actually an early build that I have of this. It's still a little rough around the edges, but you guys are going to be the first ones to actually see, logical networks and virtual gateways in Admin Center for SDN. We're also working on access control lists, so you can actually, once you can create gateways, now it becomes important you can actually start to secure your network in there. So we need to bring access control lists in as well as user-defined routing. So those are all in progress right now. We're really targeting having these all out to you by the end of the year in preview as well. There's still a lot of work to do after that, though. Probably the main big feature that we don't have or won't have in yet is load balancing. That'll be our next big task early in 2019. And then really all of the 2019 sets of features need to get added as well. We've really been targeting right now with Admin Center and SDN, making sure it works with both 2016 and 2019. So if you've already deployed 2016, you can use it now right away. We also want to add quality of service, support for multiple racks or multiple clusters. And then really one of the directions we eventually, we won't call it done until we get to the point where you can actually select your hyperconverged cluster and say add SDN, and it'll go and do the deployment for you. So that's really the ultimate goal that we want to get to. And of course, going along that with is adding servers, adding nodes, things like that. We eventually want to get there as well. So let's jump in and see what it looks like. Take a look. This is the Windows Admin Center. I assume by now you've all seen this. Here I'm adding a hyperconverged cluster. Here I'm giving it the cluster name. A lot of you may have done this already if you've configured the admin center. And now there's a checkbox for configure the network controller. We give it the REST URI for the network controller. We'll go validate that connection that we can actually talk to it. Should turn up green in a minute. Shows that it validated and it was able to talk to it. There it is, found it. And so we hit add. And then it'll go into the hyperconverged, when you click on it, UI. And right there on the left side, you can already see on the left, we have a virtual network section. This only gets added when you've added the network controller. Down at the bottom, we also have SDN monitoring. Those two sideloaded ones we'll get to last. Those are the new gateway and logical network connections that we're working on. So here we're going to click on the virtual networks panel. As you might expect from a UI, you get to see your virtual networks. You get to see your inventory. It'll come up here. I have 5 virtual networks from a number of different tenants. I can click on them, get the details, see they're healthy, see what subnets are in there. I can see what VMs are connected to them immediately, what IPs are being used on there. So it's really easy to get a lot of information with just a few clicks. Adding a virtual subnet is just a matter of clicking new. Give it the prefix you want to add. We do the parameter validation to make sure you're actually entering in a valid subnet. So it takes away a lot of the incorrect typing that you could do. And then it's immediately going to go and tell the network controller create that subnet. So you can see all those pop-ups there show that, yes, it did that. And now we have a new subnet. You can see here, even though we don't have full access control list capabilities, I did on my original subnet add an access control list through PowerShell, and we actually are already reflecting that there as well. But this new subnet doesn't have that added. So now we click down below, and we clicked on the VM, and this actually takes you a direct link to the VM section. So now we're at the VM properties, and we're going to go to the settings now of this VM and connect to that VM. And one of the things that we do is when you select a virtual switch in the network settings here of a VM, we determine if that switch has SDN enabled, and if it does, we give you the SDN options, which are, connect to a virtual network, a virtual subnet, give it an IP address. If it's not an SDN switch, then we give you the basic Hyper-V equivalent, which is, do you want to connect to a VLAN, what VLAN ID? So we have the integration for SDN going all the way down to the NIC level here. Here I'm basically selected my new subnet, gave it an IP on the new subnet, saving those settings. Let's take a few seconds for it to apply. Once we see the notification come up to tell us that it's applied, then we'll go to the VM and tell the VM to get that new address. There it is, successfully applied that new setting. So now we're going to go to the VM. We're going to switch over. This is actually also another Linux VM that I've been using for this. So I have to actually go to the Hyper-V host to connect to it because it's on an isolated network. I can't SSH into it. It doesn't have RDP, so I can't connect to it through the admin center. So we'll switch over to that now. And once we get in there, so here's the Linux VM. If I look at my ifconfig, see what IP I have, I see 10.0.4.5 is my IP. That's the old subnet. The easiest way I know of on this VM to actually tell it to renew its DHCP is to reboot it. So that's what I just did. So it's rebooting. It didn't get a notification of a disconnect reconnect because we didn't actually disconnect the NIC from the network. We literally just changed the subnet of the network from underneath it. So it didn't get that detect automatically that it's a new network. Now if we do the ifconfig, we see that we're on the 10.0.5.5. That's the address that we assigned through the admin center. And if we ping, we can still ping across to the other subnet. So everything that you need from the virtual network, the routing between the subnets, it's all there and it's all working as you would expect. So that's the basic virtual network. So we have that in place now. The other thing that's now in preview is the SDN monitoring. So you click on SDN monitoring. It's really, monitoring isn't quite the right term. It's really infrastructure health is what we show you. And we give you this really nice summary dashboard that shows you all of your SDN components and the state of are they healthy or is there an issue. So this is like the first place you go to look when you have a problem to see, okay, where's my problem? We'll give you alerts to if there are issues that need to come up. Those are still loading. It has actually a lot of components it has to talk to find all these alerts. If you drill into your network controller, so we have a section for network controller, load balancer, gateways, you can see the health of your network controller. You can see the health of the services of the network controller, all the microservices that are running within it. Are they healthy and ready? You can see the host agent status, if it's healthy. Here you can see there's an alert for the network controller that it's running out of disk space. You go down, sure enough, storage is at 90%. We show that here. You'll see all your network controllers down below. You can even get a direct link to that VM's settings, and you can remote in from there. So that's one of the great things about the deep linking within Admin Center. Load balancer, we also give you health status there as well. So here you can see the load balancer is healthy. It's loading alerts, no alerts for the load balancer. When we scroll down, you'll see the donut shows you how much IP address space is still available, so you'll know if you're running low on capacity for VIPs. And then finally, the gateway. I don't actually have a working gateway in this environment, so the pool will be empty. But we have support for multiple gateway pools as well. So you can have an IPsec gateway pool. You can have a pool that supports everything. You can have a GRE pool, and we have that in here as well. All right, let's see something brand new. So in order to be able to add gateway connections, we need to be able to add logical networks. That's what you're essentially connecting your L3 gateways to. So here is the logical network view. You get to see the logical networks in much the same way as you saw the virtual networks. You can see here we have the logical subnets defined with their VLAN IDs and the address space that you've essentially told it to use for that logical subnet. We're going to now go into the gateway connection and show how to use that logical network for those tenant VLANs to be able to connect it to a VM. And so here we've gone and you can see all the gateway connections we currently have in this environment. The first one is an IPsec connection, so it's a site-to-site. Second one is L3. L3 is basically always connected because we're really just forwarding packets in that case. And you can drill in, you can get a lot of details on this connection. Who's it connected to? What is its peer address? Are you using BGP or not? Your statistics of how much throughput, how much traffic has gone through it. So we give you a lot of detail there as well. We're still working through some of these elements, so you may see some of this UI change when we get to ship. Here is actually adding a new connection. So if we go in and say I want to create a tenant 3 connection, you give it a name, select the virtual network you want to add the connection to, the connection type. We have IPsec, GRE, and L3. We're going to select L3. Which gateway pool do you want to use? Which of the subnets you want to connect the gateway to? So there you actually saw the new subnet that I just added is showing up there. And then we have, what route do you want to send over this gateway? You get to enter that as well. And then finally, it will let you select the, which logical network you want to connect to, the tenant VLANs, and which subnet. I don't actually have any extra subnets already because my other connection used the one, but it would show up here. So it keeps track of even which subnets are used and will, filter out the ones that are already used so you can only use the connection once. So yes, that's a preview of what we are working on now. So by the end of the year, hopefully we'll have this available to all of you to use. And really, my goal is by this time next year, I will not use any PowerShell in my demo. So my fingers are crossed that I won't have to use PowerShell again next year. All right, so that's SDN in the Admin Center. So that's what we have, from Microsoft. Now, we also do have a REST API with a network control that is open to the public. So if any of you are partners, you are free to call that REST API, build products around it. If you're a customer and you want to build your own management interfaces on top of it or use this REST interface, it's available. It's also what our PowerShell is wrapped around. So PowerShell is basically doing the same thing here as well. And so one of our partners that's been working with us lately and using this interface is Five9. They have a product called the Cloud Manager, and it's integrated with SDN to be able to show you, to give you the same set of lifecycle capabilities for your VMs that are in Azure, or your VMs that are just in Hyper-V. It gives you those same lifecycle capabilities for your SDN networks as well. And so it really gives you a full lifecycle. You can do things like create your VMs, stop them. It lets you configure, disaster recovery settings, all these things that you might want to do. And it has a set of RBAC features as well. I've actually got a quick demo of it in here where you can see the SDN integration, just to see that it really does exist. And so this is the Five9 Cloud Manager. Down on the bottom is kind of their main navigation area where you can switch through the different sections of their UI. I don't actually think I started that. Oh yeah, I did. Okay, so here's their Azure section. It's just going to quickly step through. there's some reporting. There's SDN right there. We'll get back to that in a minute. And then the far right is a role-based access control. So they have the ability to basically define administrators. They have the ability to define read-only users. Be able to define basic users. So you can have a self-service user come in here and do things that are not fully as capable as an administrator. Here is the Azure integration. So you can see they will go and query your Azure VMs, let you control the lifecycle of the Azure VMs. You can see a lot of the same statistics that you would get from the Azure portal, but here it is in a single console that you can use for all of your other components as well. You have all your basic actions. This goes and then applies to Azure, your settings. And then we're going to switch over, and on the far right here is the SDN section. So if you look here, you'll see these are all the basic SDN objects that we have in the network controller. This is a network controller that they've added, SDN 8. And you can see they have actually the same basic health information that we had on our page in the admin center. But they have the full set of objects for the network controller. Logical networks, they have virtual networks, they let you do credential management, gateway connections, really kind of bringing a full set of scope of capabilities and then tying that in together with what else they have available in their management product. So here you can see the virtual networks, even virtual servers, part of your infrastructure, and really lets you drill in and see everything's there. So this is an option that's available to many of you have known Five9 for a long time and use their other products. So I encourage you to go check it out. The expo floor is now closed though, or will be, so you can't really go to the expo, but you can go to their website, and I think Constantine is somewhere in here as well, if you want to ask him questions. So that's Five9. Finally, the last thing I want to talk about, why we think SDN is going to be mainstream this year, is we've really made great efforts to make the installation easier and more reliable going forward. Now, this actually applies to both 2016 and 2019, so you don't need to wait for 2019 for this. And really, our goal is for you to be able to do fast and easy SDN deployment, whether it's with VMM SDN Express, or with the SDN Express that's built entirely on PowerShell. And the first thing that we've done is we've simplified the network topology. The network topology before, if you've looked at 2016, we asked for 3 networks: a management network, a transit network for inbound data going to the load balancer, and then a provider network for the outbound. Also in the past, when I was here at Ignite last year, I was talking about how the management network needed to be able to reach to the transit network to be able to connect to what we call the SLB VIP, or SLB Manager VIP. And we've received a lot of feedback from customers that say, well, we don't actually want to have that. We don't want to allow that traffic to go through, and they've had to do some very complicated things in their firewalls to let that traffic through. They want a complete separation of management and tenant, essentially. And so one of the things that we did is we basically got rid of that requirement to go through to allow management to go through, to require management to go through to your tenant side. And so now you can have really two truly isolated sides to your network. A management network, which is basically the same management network that you probably already have today in place, and then what we now call the provider network. We've also merged the transit network into a single provider network. So now inbound and outbound go in and out on that same network. And they can stay fully isolated from each other, even down to the physical level. This is actually something that we pushed out in an update even to the 2016. So I think if you're on the May update of server, you actually have that ability to stay completely isolated now. So we did that to kind of simplify and make it easier to understand the switch configuration. We also basically rewrote our SDN Express tool to be able to be much easier to use and much more reliable. We do a lot more validation than we used to of the parameters. We built a UI on top of it, so now it will do an interactive set of steps to walk you through, entering your information, and it validates it in real time, so you know right away if you entered in a subnet that's not valid, or an IP address that's not in a subnet, or if your end of your pool came before the beginning. That's actually happened with some customers. We also made it so you can load as a PowerShell module, so if you have your own automation for deployment, you can load SDN Express, a PowerShell module, and then call these functions. There's an add SDN Express host function that'll add a new host to your controller. There's an add a MUX function that'll add a new MUX. All you have to do is deploy the VM, which we actually have a function for that too. And it'll go and create all these things. Quick view of the architecture of what it looks like with the kind of the change. So on the left side in blue is your management space. So it's again, you can use the same management network you already have. The only requirement is that we ask when you use SDN Express is that you define a range of addresses that can be statically assigned to your SDN VMs that you create. On the right side in orange, the dark orange is your provider network. This is really where all the tenant traffic goes. And then really all the communication there that the tenants do when it's going east-west within the virtual network is encapsulated with VXLAN, or if it's going to the MUX, it's encapsulated with VXLAN, and then after it passes through the gateway or MUX, it goes out on the orange path up to your router and to your physical network. Now, we've simplified this a lot on the left side, but you still do have to connect, at some point, because we do everything at layer 3. Our load balancer in particular, I talked about this also at past Ignites, is layer 3 and connects to your physical network through BGP, so it can advertise routes up to the network and be able to really be dynamic and not have you go in and change the configuration of your switch every time you add a new subnet. But that requires you to talk to your network admins, and I think most of you in here tend to be closer to the server side of the IT department. So I put together a slide that will help you in talking with your network admins. Really, what do you need to ask them for when you're working with them? Because really, if I go back one, the network admins pretty much always own the core backbone network of whatever your data center or your environment is. Who owns the router and who owns it? They would actually also typically own the router as well. The top of rack switch, we see that as being kind of a gray area. Oftentimes, if all you're doing is layer 2 VLAN configuration, then the server admins may do that, and they just pass those VLANs up to the router, which is then owned by the network admins. So there is some variability there. If you have an L3 switch, then you would have the router in there as well, and then again, depends on in your particular organization who owns what. But here are the things that you need to talk to whoever, wherever you do that handoff, you need to talk to them about. First of all, you need IP address space, right? You need a section out of your management space for use for the components to be able to talk to each other. That should be fairly straightforward. Your provider address space, this is for your encapsulated packets. These are also known as VTEPs, or you may know them as VTEPs, virtual tunnel endpoints. Those go on the provider network. It's also the inbound and outbound for your load balancer. Those are the only two that get configured on a VLAN, right? You configure those on a VLAN so that, you have a router to connect to, and you connect a router interface in the switch. Everything else, your VIP subnets, your public, private, and GRE VIPs, those all get advertised through BGP up to the physical network, because you're going to be adding and removing those, well, probably mostly adding over time. And so you need those to be dynamically announced. You don't want to go and change your switch configuration every time you add a new, public internet, /28 or whatever, small chunk you buy of IPv4 space. So we advertise those through BGP so we can do those advertisements very dynamically. So but you do need to ask your network team, okay, allocate these or get these address spaces for me. Once you have the address spaces, then you need to talk to them about doing what's called a layer 3 handoff. This is really where, the MUXs and the gateways in the SDN really look like routers to the rest of the physical network. And so those routers need to send layer 3, and the network teams often, call that a layer 3 handoff, where you're basically setting up the physical network to say, okay, my next hop for this subnet is down in my SDN environment. And that's really the extent of what the network team needs to do, right? And since we do use BGP, they need to allocate ASNs for, the SDN end of things to use. They need to allocate an ASN for the Tor if the Tor doesn't already have one. So those can get configured. That's how the BGP peers uniquely identify each other. They need to enable peering at least up to the first hop of layer 3. They don't have to go beyond that. They can use static routes beyond that, OSPF beyond that, whatever the network team's comfortable with. But up to that first hop, you need BGP. So that's usually in the layer 3 switch at the top of the rack. They have to enable the subnets that they've assigned to you to get advertised, because they don't want you to advertise, 0.0.0.0/0, because that would be a big problem, because then you would get all the traffic for your environment. So they generally limit what you can advertise. So they need to configure that as well. And then one thing that they'll generally want to do, because we advertise all of our addresses in very small /32 chunks, they have to do what's called an LE32, or basically let 32 addresses go through. They can aggregate after that to collapse those /32s, or even you can aggregate in the Tor to collapse those /32s into a larger subnet. But you still have to basically say, though, that these 32s can come up so they can be aggregated. Depending on if your Tor is your layer 3 switch or not, You may configure BGP there. If not there, then it would be in the first hop of the router that's above it. And that would, again, tend to be, if it's the separate router, it would tend to be owned by the network team. But if it's the L3, then it may be the server team that owns it. And then you have to do just basic VLAN configuration for your management and provider subnets. One last thing is, because we are encapsulating packets on the network, you need to have the MTU set a little bit higher on your physical network. We generally say 1660 or higher. That'll give you enough room above the standard 1500 to be able to do 2 VXLAN encapsulations on top of each other. There are a few cases where that happens if you're doing load balancing in particular. A few tips for deployment. So I kind of threw a couple of these slides together at the last minute because after talking to a lot of you this week in the expo floor, I put a couple extra slides in that talk about some of the things that have been asked. When you deploy with SDN Express, and whether you're doing with VMM as well, you'll generally set up your host first. You'll get the host added to VMM, or you'll get the host configured with your cluster. You'll set up your switch embedded team or set switch. You get all that up and running first, and then you're going to add SDN on top of that. And I would also recommend that if you are using S2D, you do all the validation of the storage, make sure your storage cluster is reliable and all of your storage is very healthy first. SDN Express, when we run it, we'll run it in a minute here. It has a UI. That UI is a great tool for creating, you can either deploy immediately from the UI, but you can also export that configuration and then reuse that configuration later on. So it's a good way to, build essentially a template for, being able to redeploy over and over again, maybe even in different environments. There are a number of different ways that we deal with passwords now, because it's not a good idea to just put a password in the config file. So now when you do go through the UI and ask you for a password, it encrypts it using the local machine certificate. Which means, though, that it can only be then SDN Express run on that local machine. If you take it to a different machine and run it, it won't be able to decrypt the password. So you have a few other options. You can generate, the encryption yourself using PowerShell. We do convert to secure string and then convert from secure string to get it into back into the encrypted form. You can specify the credentials on the command line when you run SDN Express, wherever you run it. And if none of those actually, are available, when the script runs, it'll fall back to prompting you for the password. So just want to cover that there as well. And then finally, there are a lot of questions that come up around the certificate stores. How do you manage certificates? When SDN Express or VMM creates self-signed certs, where do they go? And so this is kind of just a cheat sheet that I put together for you to kind of give you some information about that, right? Where does the network controller look for certificates? Well, it looks in the My store, so this is its personal store of the machine, for the REST certificates. So this is what it's going to use when it encrypts and where it needs the private keys to be able to do the encryption. And it looks for its own cert there as well. But then when it gets a encrypted packet, an SSL encrypted packet from somewhere else, and it needs to look up to see, hey, do I trust this other machine? Then it looks in the root store for those. So in the network controller, you'll pretty much see certs in the root store from every other component because it has to talk to everybody. All the other components, on the other way around, they generally only need, of course, they need their own certificate in the My store. But in the root store, then, they only need then the REST certificate of the network controller, because that's really the only, other component that they need to trust. The certificates may contain private and public keys. The root only contains the public key, because you generally don't need the private key in there, because you're just verifying that what you receive is valid. A few other things that customers have run into, the node certs need to contain the FQDN, and you need to only have one of those in the My store, because some of the components in SDN will go and look up in the My store for a certificate that matches a subject name. If you have two of them there, you may get a different cert depending on what order it enumerates them in. So you need to make sure that you only have one cert there with the subject name that matches FQDN. Certs need to have the capability to be a client cert and a server cert, and so we have OIDs for that define that. And so when you create through VMM and SDN Express, we do self-signed certs. If you're using a CA for generating the certs, you're not going to use self-signed. You need to make sure the certs you generate with that CA, have those OIDs in them. Another common issue that customers have run into is if they do use a CA and they generate it in a way that the issue to doesn't equal the issue by in the certificate, and you put it in the root store, that's actually an invalid certificate from the perspective of from Windows and its entire security subsystem is concerned. And so actually the the SSL encryption within Windows, not even within SDN, will actually, when it hits that cert, it'll say, oh, there's something wrong here, and it just stops. And we actually then you don't get your communication going through. Those need to go, and now if I remember off the top of my head, into a different store. I don't remember which one it is now off the top of my head, but it is a different store that they go into within the certificate manager. SDN Express now in the new update, if it finds a cert that matches what it needs for its requirements, particularly those OIDs and the subject name in the root store or in the My store, it'll use that cert now. So it doesn't try to recreate a new cert if there's already one there that matches. So that's actually should be something also that'll help prevent duplicate certs. All right, my final demo, and really just before I wrap up, let's actually see the new SDN Express in action. This is just a quick demo. And then I'll still have some time for questions after this, so that's good. So here we go. We're going to run SDN Express. So one of the other things that we changed is there are no longer a lot of prerequisites. You basically download it from GitHub and run it. In this case, we're importing the SDN Express module.psm1. That is the module that has all the functions. Just do a get help real quick. You can see the set of functions we have available for configuring your controller, adding a MUX, adding a host, things like that. We're going to instead run it just by itself, and when you do that, you get the SDN Express deployment wizard. And so this is a wizard that will basically walk you through the configuration of SDN. It gives you a bunch of links directly to help topics, and really it prompts you through, here's how here's all the thing it needs to know to create the VMs it's going to need for SDN. It gives you a browser to find your VHD. You enter in the path to where you want the VMs to go. In this case, I'm doing an SMB share, maybe a cluster shared volume if it's an S2D cluster. Give it the domain this is all for the VM creation, customization. This all goes in an attend file so that I can create a VM. It's basic VM creation. And then we need to know about the management network because we need to assign addresses from the management network. We don't actually put this management network in the controller because the controller actually doesn't necessarily need to know about it unless you're going to apply policy from it. But we do need it in order to be able to assign addresses to the VMs that we create and to be able to configure the basic networking. So again, this information from the management network basically goes into the unattend file of the VM that gets created. We're entering in the DNS. You can see we're actually validating the IP addresses as you type it. It doesn't become valid until it's complete. Now the provider network we do put in the network controller, so that will get created as a logical network in the network controller. We enter in all this information. We validate that your gateway is within your subnet prefix. Same thing with your first and last IP address. We validate those are correct and that the first comes before the last. I'm going to put in a new MAC address in here because in this environment I actually do multiple deployments on the same VLAN. So get that in there. Enter in the rest name. Now I give you an option for multi-node or single node. If you do have a 2-node cluster, you can't put 3 network controllers on there. So in that case, you would deploy single node, set it up as a highly available VM, and then you get failover there as well. Load balancer MUX configuration. How many MUXes do you want? You just drag a slider to say how many. 2 is the default. Your initial VIP address spaces you enter there as well. Same thing with gateways. How many gateways do you want? You can drag just to say how many. It'll then figure out how many VMs to create and how to allocate addresses from the management network. Finally, your BGP configuration. Give it the ASNs, the IPs, and then hit next. It'll give you a summary, and then there's an export button right there. You can export. It'll save it to a file, a PSM1 file, and you can save that then for later use. But if you then just hit OK, it'll go and do deployment. I sped this up. The actual deployment takes about 35 minutes, depending on how fast your VHDs get copied to wherever your location is for them. Network controller itself, creating that also takes probably about 10 minutes of the 35 minutes that it actually takes. But in this case, I sped things up. You're going to see 35 minutes within about 30 seconds. But when it completes, here it's now actually deploying the gateways, configuring those. It did the MUXes in between. Those scrolled by quickly. It's done. This is now ready. If this was an S2D cluster, you could add it to the HCI extension as you saw earlier, and now actually create VMs and connect them. And so that's the management experience and the deployment experience and the features. I mean, it really, I think I covered everything in there. We do have a lot of good features, a lot of features that everyone can use from 2 nodes and up. It's very easy to management, getting easier basically every month with Admin Center and with improvements that are coming to VMM on their semi-annual cadence. And then, of course, we're making it easier to install, so installation should no longer be your bottleneck. We did a blog series recently on the networking team, so a couple last bits before you go or ask questions. We did a top 10 blog series. Encourage you to check it out. We have a bunch of SDN topics here as well. That's on the TechNet blogs. We're going to continue to do on a weekly cadence new updates, new posts here. So I encourage you to keep up on there. We've been really active there lately as well. And then tomorrow we have another session. I'll leave the slide up for a few minutes, maybe while we're asking questions. So if you want to scan those QR codes or take a picture. There's a session tomorrow. We talk about hybrid networking, including everything all the way from the host on one end on-prem and then all the way to your server in Azure. What are the things you need to think about as far as the network goes, or what are the things that we're doing in Windows to make that work really well? Link to the deployment tools on GitHub is there. Link to our SDN documentation, networking blog as well. Those are all QR codes. And then tomorrow's session's there, and this one, which you're currently in. With that, I actually got done with 5 minutes for questions. Please fill out an evaluation. Thank you for coming. Thanks to everyone that came by the expo floor this week, asking a lot of great questions. It was it's always very enlightening hearing about your experiences, and thanks for coming to the session. And have fun, and remember what I said about virtual networking when you're in line tonight at Universal. Thanks.